All right, this is the continuation of the power function worksheet that we started. This is the second example. I got us started a little bit by writing out x plus 2 cubed, which means take it times itself 3 times. So I wrote that out for us. Now we're going to FOIL. I'm going to choose to leave x and multiply by x at the very, very end. So I'm going to multiply x plus 2 times x plus 2. So x times x gives me x squared. X times 2 is plus 2x. 2 times x plus 2x. And 2 times 2 is 4. I'll multiply these two together. So again, we're FOILing. X times x is x squared. X times -1 is negative x. 2 times x is plus 2x. And 2 times the -1 is -2. So line 3, I'm just going to combine like terms inside my parentheses. So I have x squared plus 4x plus 4 times x squared plus x minus 2. Now we're going to multiply. Let's change colors. We're going to multiply the trinomial times the trinomial. So I'll take x squared times x squared, then x squared times x, then x squared times -2. So let's do that first. X squared times x squared is x to the 4th. X squared times x is plus x cubed. X squared times -2 is -2x squared. Now that we've done that, let's multiply everything by 4x. So we have 4x times x squared would give me 4x squared. 4x times x, oh, I'm sorry, 4x cubed. 4x times x gives me 4x squared, and 4x times a -2 is -2, -8. X. All right, now that we've done that, our next process will be to multiply everything by 4. So 4 times x squared is 4x squared. 4 times x is plus 4x. And 4 times a -2 is a -8. Now we will combine like terms. So we have an x to the 4th, and I don't see any others, so x to the 4th. A 1x cubed and a 4x cubed gives us 5x cubed, and there are no others. A -2x squared and a positive 4x squared give me 2x squared. 2x squared plus 4x squared is 6x squared. A -8x and a positive 4x will give me -4x, and my constant term is -8. The last step, we want to leave this for the last. We're going to multiply everything by the x. X times x to the 4th is x to the 5th. X times 5x cubed is 5x to the 4th. X times 6x squared is 6x cubed. X times -4x is -4x squared. And x times a -8 is -8x. And there we have our polynomial all FOILed out. This is in standard form. That is our polynomial in standard form. All right, we can find our x-intercepts by setting each of the factors equal to 0. So if I set x equal to 0, I get 0. I know 0 is going to be an x-intercept. If I set x plus 2 equal to 0, subtract 2, I know -2 is going to be an x-intercept. if I set x minus 1 equal to 0 and add 1, I know x equals 1. So my intercepts, I know my x-intercepts. They're going to be 0, 0. I'll have an x-intercept at 0, 0. I'll have an x-intercept at -2, 0. And I'll have an x-intercept at 1, 0. Those are x-intercepts. If I peek at my graph, there they are, -2, 0, 0, 0, and 1, 0. This little guy just wants to float around. All right, and that was 1, 0. Again, looking at my graph, I want my domain and my range. My domain are the x values. So I know that this is moving forever to the left. And up here, it's moving forever to the right. Not only is it going down forever, but it's also moving gradually to the left. Not only is it going up forever, but it's also moving gradually to the right. Try to make that a little bit smaller. So our domain is -infinity to +infinity. And let's take a look at our range. Range is always bottom to top. So our bottom y value is -infinity, that's going down forever. And our highest y value, bottom to top, is +infinity because that's going up forever. So our range is negative to +infinity. It is continuous. We never have to pick up our pencil to see that, to draw that graph. So that makes it a continuous function. The intervals over which the graph is increasing and decreasing. So this is where Ms. McFadden always shades her x-axis. We're shading the x-axis. All right, so as we move left to right, as our graph moves left to right, it's increasing all the way up to this point right here. So what are the x values over which the graph is increasing? The x values are -infinity up to -0.5, from -infinity to -0.5. So increasing -infinity to -0.5. Then part of the graph starts going down. So this is where the graph is decreasing until it gets to this point right here, which looks like it has an x value of +0.5. So the interval over which the graph is decreasing would be -0.5 to +0.5, it looks like. So decreasing between -0.5 and +0.5. And then after that, it looks like the graph is increasing again. It's going up. So increasing on the interval +0.5 to +infinity. So increasing +0.5 to +infinity. Okay, so that increasing, decreasing is always inside parentheses, and we never use brackets when we're doing increasing, decreasing constant. We only use parentheses. Okay, let's talk about the max and the min. So this point is the max. That looks like -0.5, 2.5 maybe. -0.5, 2.5, good enough. So -0.5, 2.5. And the min, so that's our max. And the min would be this point. I'd say +0.5, -4.2-ish. +0.5, -4.2. Good enough. All right, our leading coefficient and the degree. That's why we distributed and FOILed all of this out and multiplied it out so that we could see what is the leading coefficient and what is the degree of the polynomial. The leading coefficient is 1 and the degree is 5. The highest power is the degree, and the leading coefficient is the number that leads. It's in the lead. It's the coefficient that's in the lead. All right, and behaviors using limits. So this is one of the things we definitely want to get to. This end behavior down here, let's talk about it. So the graph is gradually moving to the left. So my x values are approaching negative infinity. So we'd say the limit of our function as our x values approach negative infinity equals, now the limit itself are the y values. So we want to say, what are the y values doing? They're also approaching negative infinity. And then we have the other end behavior up here. So as the graph is moving upward, it's also moving outward to the right. So my x values are approaching positive infinity. So the limit of f of x as x approaches positive infinity equals, so remember the limit is the y value, and the y values are also approaching infinity. So the limit is infinity. All right, I hope that helps you guys. Have a great day.